Question 1. A development team wants to deploy a new web application to AWS quickly without managing the underlying servers, load balancers, or auto-scaling configurations. They prefer to focus solely on their code. Which AWS service is best suited for this requirement? Option A, Amazon EC2. Option B, AWS CloudFormation. Option C, AWS Elastic Beanstalk. Option D, Amazon ECS. The correct answer is AWS Elastic Beanstalk. Here's the explanation. AWS Elastic Beanstalk is a platform as a service (PaaS) offering that automates the deployment and management of underlying AWS infrastructure, EC2, ELB, ASG, etc., allowing developers to focus on application code. EC2 is IaaS, requiring manual server management. CloudFormation is infrastructure-as code for provisioning resources, not application deployment. ECS is for container orchestration, which still involves more operational overhead than Beanstalk for simple web apps. Question 2. A developer needs to ensure zero downtime during application deployments to an Elastic Beanstalk environment and wants an easy rollback mechanism in case of issues. Which deployment strategy should they choose? Option A, all-at-once deployment. Option B, rolling deployment. Option C, rolling with additional batch deployment. Option D, immutable deployment. The correct answer is immutable deployment. Here's the explanation. Immutable deployments launch a completely new set of instances with the new application version, then swap the CNAME, DNS alias, with the old instances. This provides zero downtime and an easy rollback by simply terminating the new environment if issues arise, leaving the old, working environment untouched. All at once causes downtime. Rolling and rolling with additional batch reduce downtime, but don't provide the same easy rollback as immutable. Question 3. A company uses Elastic Beanstalk for its web application and needs to perform custom actions during deployment, such as installing specific OS packages, modifying Nginx configuration files, and running a database migration script. How can they achieve these customizations within their Elastic Beanstalk environment? Option A, directly SSH into the EC2 instances after deployment and manually apply changes. Option B, use AWS Systems Manager automation documents. Option C, include "EB extensions" configuration files in their application source bundle. Option D, define custom launch configurations in the auto-scaling group. The correct answer is include "EB extensions" configuration files in their application source bundle. Here's the explanation. "EB extensions" are configuration files placed in a ".platform" directory within the application source bundle. They allow developers to customize their Elastic Beanstalk environment by installing software, running scripts, modifying server configurations, and defining custom resources during deployment. Options A is manual and not scalable or automated. B is for broader fleet management and remediation, not direct Beanstalk environment customization during deployment. D is for EC2 instance properties, not application-level customization scripts or server config. Question 4. A company is evaluating migrating an application to the cloud. They are particularly interested in minimizing operational overhead, paying only for actual compute usage, and having the application automatically scale from zero to handle unpredictable traffic spikes without manual intervention. Which architecture model best aligns with these requirements? Option A, traditional architecture using infrastructure as a service, IaaS, virtual machines. Option B, traditional architecture using platform as a service, PaaS, with continuously running instances. Option C, serverless architecture using function as a service, FaaS. Option D, On-premises architecture with dedicated physical servers. The correct answer is serverless architecture using function as a service, FaaS. Here's the explanation. Serverless architectures, FaaS, are characterized by no server management, automatic scaling from zero, and a pay-per-execution billing model, directly addressing the goals of minimizing operational overhead, cost optimization for variable workloads, and automatic scaling for unpredictable traffic. Question 5. Which of the following application characteristics makes it a strong candidate for implementation using a serverless function as a service, FaaS model? Option A. Requires continuous, long-running background processes with fixed resource allocation. Option B. Demands deep operating system-level access and custom kernel modules. Option C. Exhibits highly variable, event-driven workloads with unpredictable bursts of activity. Option D. Necessitates maintaining persistent, in-memory state across multiple invocations without external storage. The correct answer is exhibits highly variable, event-driven workloads with unpredictable bursts of activity. Here's the explanation. Serverless functions excel with event-driven, bursty, and unpredictable workloads because they automatically scale up and down, even to zero, and charge per execution. They're typically stateless and have limited execution durations, making options A, B, and D less suitable. Question 6. When discussing serverless functions, the term cold start refers to which phenomena? Option A. The initial deployment of a function's code to the cloud provider's infrastructure. Option B. The time it takes for a function to connect to an external database for the first time. Option C. The latency experienced during the first invocation of an idle function as its execution environment is initialized. Option D. The process of scaling down function instances to zero when there is no incoming traffic. The correct answer is, quote, the latency experienced during the first invocation of an idle function as its execution environment is initialized. Quote. Here's the explanation. A cold start is the increased latency that occurs when a serverless function is invoked after a period of inactivity. This latency is due to the time required for the cloud provider to initialize a new execution environment, e.g., spinning up a container, and load the function's code and dependencies. Question 7. A data science team needs to regularly run thousands of independent, computationally intensive jobs for genomic analysis. They want to avoid managing underlying servers, optimize costs by using spare capacity, and scale compute resources dynamically based on the workload. Which AWS service is best suited for this scenario? Option A. AWS Lambda. Option B. Amazon EC2 with auto-scaling groups. Option C. AWS Batch. Option D. Amazon EKS, Elastic Kubernetes Service. The correct answer is AWS Batch. Here's the explanation. AWS Batch is a fully managed service designed for running high-volume, repetitive batch computing jobs. It handles provisioning, managing, and scaling compute resources, including leveraging EC2 spot instances for cost optimization, and is ideal for parallelizable, computationally intensive workloads like genomic analysis without direct server management. Question 8. You are setting up an AWS batch environment. You have defined your application's Docker image and resource requirements, and you want to ensure jobs are processed efficiently on EC2 instances provisioned and scaled automatically by AWS. Which 3 core AWS batch components are essential for this setup? Option A. Job definitions, job queues, and compute environments. Option B. Container registry, S3 buckets, and CloudWatch logs. Option C. AWS Lambda functions, step functions, and DynamoDB tables. Option D. EC2 instances, auto-scaling groups, and load balancers. The correct answer is job definitions, job queues, and compute environments. Here's the explanation. Job definitions specify the container image and resource requirements. Job queues hold the submitted jobs. Compute environments provide the underlying compute resources, like EC2 instances, where jobs run, and AWS Batch manages their scaling. Question 9. A developer is choosing between AWS Lambda and AWS Batch for a new data processing task. A task involves processing large video files, which can take several hours per file, and needs to handle hundreds of files concurrently. Which service is the most appropriate choice, and why? Option A, AWS Lambda, because it's serverless and ideal for event-driven processing of individual files. Option B, AWS Batch, because it's designed for long-running, compute-intensive tasks and can scale to handle high concurrency. Option C, AWS Lambda, because it offers unlimited execution time and memory for video transcoding. Option D, AWS Batch, because it is cheaper for short-duration, high-frequency tasks. The correct answer is AWS Batch, because it's designed for long-running, compute-intensive tasks and can scale to handle high concurrency. Here's the explanation. AWS Lambda has a maximum execution time, currently 15 minutes, and is for short-running, event-driven functions. AWS Batch is built for long-running, computationally intensive tasks that can take hours or days, making it suitable for processing large video files. It also handles scaling for high concurrency. Thanks for watching. Please subscribe to my channel.